Hello friends, today I would like to prove those three limits with you, and we are not using the rule of L'Hopital, so no differentiation is involved. Let's call it pure skill. All right, we're gonna solve it, and this is still kind of variations from time to time of the very important limit sine of x divided by x as x is approaching 0. Okay, so let's start with the first one. This is a limit n is approaching infinity, and we are having n times the sine of pi divided over n, right? So is it obvious it's approaching pi? Well, you see, if you multiply it times, let's say, pi divided by pi, you're not changing anything, right? But we can rewrite this as, well, let's take pi in front of the limit. We have a limit n towards infinity of n divided over pi times the sine of pi divided over n, which can be written as pi times the limit n towards infinity. And now we're just rewriting it as sine of pi divided over n divided over, well, you see we make a reciprocal out of this, so it's pi divided over n again. And now you see, as n is approaching infinity, the denominator is approaching 0, and the argument in the sign is also approaching 0. So we're basically dealing with the limit x towards 0, sine of x divided over x, and this is 1 if you remember that. So that limit is 1, and we get pi times 1, which is pi. First limit, check. Now let's do the second. This is also nice. I like this. Once again, pure skill, no L'Hopital. So we have 1 minus cosine of x here, divided over x squared. Well, you see, 1 minus cosine as x is approaching 0 is approaching 0 itself, because cosine is 1 at 0. So we have 1 minus 1 divided over 0. It's undefined, right? And, well, I'll make it maybe one day and we'll prove the rule of L'Hopital as well, but we can do it here differently. Let's multiply times 1, which we rewrite this way. Okay, we're not changing anything. What we have in the numerator is x towards 0, and now you see we have binomial formula, which is saying we have 1 minus cosine squared of x now, divided over x squared times 1 plus cosine of x. The trigonometrical formula, sine squared plus cosine squared, sine squared plus cosine squared of every angle is giving you 1. That's why 1 minus cosine squared is giving you sine squared. So we're having limit x towards 0, sine squared, and now look what I'm doing. I'm writing it as sine of x divided over x times 1 more sine of x divided over x. This is how I rewrite sine squared of x and sine squared of x and x squared as two fractions. And now what we have is still 1 divided over 1 plus cosine of x right here. And what you see, this is the limit we know. It's 1 as well. So what we have is 1 divided by, well, if x is approaching 0, cosine is becoming 1. 1 plus 1 is 2. It's a half. And now look carefully at this limit and tell me truly, would you have expected that? Well, I wouldn't. That's why it's so nice. Okay, and we don't do L'Hopital. Like, it's a machine you learn at the university and everybody's applying and everything is cool, but this is nice to be able to solve it differently. Okay, now the third one, also nice. Limit x approaching a, sine of x minus sine of a divided over x minus a. What we need here is a special formula for trigonometry, and let's write it down. Let us consider maybe on the next page what is happening if we're having cosine of x plus a divided by 2 times the sine of x minus a divided by 2, and let's multiply it times 2 as well. So what will happen here? Well, you see we're having 2, let's open the parentheses. So this is the cosine of x divided by 2 plus a divided by 2 times the sine of x divided by 2 minus a divided by 2. We're having now 2 times, well, now we're applying the additional theorems. So this is cosine of x divided by 2 times the sine of, no, I'm having the sum of the cosine, my bad. Have to be concentrated. So this is the cosine of a divided by 2 minus sine of x divided by 2 times the sine of a divided by 2. So this is the first. And now we also have to do it with the sine. This is the sine of x divided by 2 times the cosine of a divided by 2 minus the sine of a divided by 2 times the cosine of x divided by 2. Cannot simplify it, I'm sorry. Or shortcut, I would like to prove it properly. And now we have to multiply it all together. It's not so much, but still we have to pay attention what we're doing. So we're multiplying firstly those two terms, okay? So do we have something in common? No, we don't. So we're just writing down what we have. So we still have 2 times, let's open the parentheses. So we have cosine x divided by 2 cosine a divided by 2, cosine x divided by 2 cosine a divided by 2, times sine of x divided by 2, sine of x divided by 2, and times cosine of a divided by 2 again, which brings it to square. All right. So that's the first multiplication, right? Those two terms are same. That's why I'm taking a square. All right. What is happening here? Well, let's maybe multiply this one times that one. And now we have the sign in common. All right. So we keep minus. Let's maybe switch the color. We have minus sine squared of x divided by 2. This is what we get here. Sine squared of x divided by 2. Sine of a divided by 2. Sine of a divided by 2. Let's move my picture. Okay, and we have cosine of a divided by 2 as well. Cosine of a divided by 2. This is the second multiplication. What is the third? The third is we take this one times that one. What do we have in common? The cosine, and we still have minus. So we have minus cosine of what? This is x divided by 2 squared. Got it? And then cosine of a divided by 2 times sine of a divided by 2. Cosine of a divided by 2 times sine of a divided by 2. We got it as well. And the next one, the last one, is a multiplication of this one times that one, and we have cosine squared. Am I doing correctly? No, my bad. I have to multiply this one times that one, right? And what we have is sine of a divided by 2. So we have plus sine of x divided by 2, sine of x divided by 2. We have sine squared of a divided by 2. And we are also having cosine of x divided by 2. Okay. Can we now simplify it somehow? Let's see. So what we have is, if we solve the parentheses and we put 2, for example, here, we can bring it together. It's going to be 2 sine of x divided by 2 cosine of x divided by 2. And maybe you remember the formula. 2 sine of x divided by 2 cosine of x divided by 2 is just sine of x. So this is what I have here. Sine of x times cosine squared of a divided by 2. Now we can do the same also here. It's just minus sine squared of x divided by 2 times, we have just sine of a. We have the same here, so it's minus cosine squared of x divided by 2 times sine of a. And we have plus, this is sine squared of a divided by 2 times sine of x. Now, if I take sine of x out of the parentheses, I would have sine squared plus cosine squared, which is 1. So those two are just giving me sine of x. And if I take minus sine of a here and there outside of the parentheses, I would have cosine squared of x divided by 2 plus sine squared of x divided by 2, which is 1 as well. So we have, that's the proof. Okay, hope you could follow me, otherwise you have it on the video. I do not. So I have to do it. I had to do it just by my own. All right, so we use it now, and we just rewrite it as limit still x divided approaching a 2 times, we have the cosine x plus a divided by 2, x plus a divided by 2 firstly here, and then we have sine of x minus a divided by 2, sine of x minus a divided by 2, and we are dividing it by x minus a. All right, is it better? Maybe not immediately clear that this is better, but if we are multiplying it times a half over a half, so we're multiplying times 1, which we are rewriting as a half divided by a half, this 2 is gone, and now we have division by 2 in the denominator. So let's write it down. We have a limit, x is approaching a. We have cosine of x plus a divided by 2 times the sine of x minus a divided by 2. Now maybe you see why I was doing all the preparation. Well, we still have a half, which is moving here, and this is x minus a divided by 2. And now you see this is the same argument as we are having here. And since if x is approaching a, x minus a divided by 2 is approaching 0, we know that this limit is going to be just equal to 1. So what we have is the limit of x approaching a for cosine of x plus a divided by 2. If x is approaching a, we have a plus a. 2a divided by 2 is just cosine of a. Isn't that nice? I think it's absolutely marvelous. Thanks for watching. I hope you enjoyed it at least half as I was enjoying it. And see you guys in the next video. Bye bye, all the best.